Hey everybody, this is Larry. This is 4th of July here in the year 2025. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I am going to do a random extra problem because, well, today we had an easy one. And we'll put us any difficulty. We have 647 left, I think, maybe, problems. Actually, we want to keep only algo. Okay, so only 282. Maybe I need to do the other ones like JavaScript. I don't know. Do I need to do pandas problem, for example? Are there really 343 pandas problem? Wait, that doesn't seem that interesting. Oh, I don't know. Just not my strength in any case. And JavaScript, there's actually not that many other type of problems, to be honest. Oh, 300 database as well? How many problems am I missing then? Oh, maybe some problems are pandas and algorithm. Maybe. I don't know. It's very weird. The intersection is greater than the all topic part, so I don't know if you sum it up or whatever. Anyway, all right, let's take a random problem. Let's click on a pick one, and let's go. We have a hard problem today, which is kind of nice, in the sense that I haven't been doing many lately, so we have 76 of these anyway. So yeah, let's go. We have 736 parse Lisp expression. You're given an expression with Lisp-like language. That already sounds kind of annoying, which is okay. If you watch my daily video, today I have energy, so I try to take advantage of it. So okay, so you have a lot of syntax stuff. Let's take a look at the example because I'm too lazy to read them all. So you have, yeah, like Lisp type language. I actually don't know Lisp that super well. It's been a while. It's how I do stuff with Emacs, but I don't remember. But yeah, okay. So you have all these. You have three things, and that's it, right? A let, an add, and a moat, and then some stuff about concept. Right. The first one, add, x, let. I'm reading real quick. So the x is equal to 1, y is equal to 2, x is equal to x plus y. Oh yeah, this sets to 3, and then the last evaluation is 5. Okay. This sounds like a very annoying problem. Okay. So what am I doing? I mean, given the n is 2000, you could do an n squared thing for sure. I think this is a very whatchamacallit, recursive descent type E problem. How does let work? Okay, let is just everything. Okay. I'm double checking basically with this problem. There are liberties to be taken with respect to what a limit set of it is. So I'm just trying to make sure that I understand all the limitness of this part of the problem and figure out a strategy for, well, dealing with the limited part of this problem. Okay. Like, is let always the first object, or would there be let in the middle? Oh, there is let in the middle, so I'm wrong. Hang on. So let returns and then there's an expression, and then it evaluates the expression. Okay. Actually, I don't remember this. Okay. So recursive descent, right? Yeah, I mean, you just have to define the language and process them, and we have 3 things we have to do, right? So you have this, you have this, and what they do is mostly self-explanatory, right? The let is just, yeah, and then okay, how do I want to write this, right? It's just about writing, the way that I think about it is just I write it in terms of the is it called lambda language? No, the just the language. Honestly, natural language processing and all these things, or not even that, but I'm so out of shape with respect to like what all the actual vocabulary is. Usually on, especially on the algorithms part, I feel like I'm stronger just from years of whatever, but definitely I am weaker on like computational complexity type thing and language type things of, you know, how to kind of talk about it, to be frank. There are probably better resources to it, but you know, but this is still Leetcode, so let's get started. I think the first thing we want to do is, okay, so I'm trying to, I forgot what this is called. Is it just like an expression? Okay. So there are, you know, things you want to write, and then now here's an expression, right? So maybe parse expression, something like that, or get expression maybe. I always forget all the terms. It's been a while. Actually, parse expression is fine. And then basically what this does is that given a string and a what's it called, like a current pointer. Like I said, I don't remember all the vocabulary, the precise vocabulary for this. I'm a little bit weaker, but I do have the idea, right? So here, and here, maybe we have a peak. And what peak does is just take a look at the top of the, or the next character without moving, right? And that just return expression of current. And then basically we are writing a parser. I mean, there's no way around it, right? And then there's consume maybe. And maybe some people write it either one or like you could treat consume as peak and then moving the counter, or you can, you know, yeah, and then current, something like that, right? Consume and return the next character, right? And then now expression could just be anything, right? So then now we have to try to figure out, and usually there's actually a more, this isn't quite precisely the language, and this is probably what you have to figure out. And the expression is just one of three things, and the thing that differentiates it is kind of like, you can think about the first thing as a type, right? Okay, but well, kind of in the sense that, okay, if peak is not equal to oops, the other one. Because it has to begin, or it has to begin the parent, right? Then here we assert false because it's just, well, maybe something is wrong, but we can do it this way. And then otherwise we consume the left parens, right? And then yeah, I guess because of this left paren it thinks is whatever, but maybe we could do. A lot of auto weirdness on the editor, but in any case, yeah. And then now maybe now we get the current token, yeah, because this is where you define language, right? The current token. So maybe we could get a word or something. Yeah, okay. And here maybe I could have a helper for it. I'm not sure about getting a word, but you can also just write like, wow, peak is not equal to an empty space, which is what ends the token. Then we consume, right? So maybe c dot append consume or something like that. And in this case, technically speaking, if you want to be lazy about it, you could already differentiate with just one character, right? Like let, add, and mode has one character. Like the first character is different, but we can write something like that, right? And then now, I'm writing this in a lazy way, but and here we can switch, match, I think. So we have case, we have a let. So now we have a let statement. So then now we, yeah, we return parse let maybe. one thing I'm just thinking about is whether I should make the left and the right parens. I mean, I already kind of started up that way, but it should be part of the expression or the sub-expression, and which one is easier? I don't know, to be honest. It's not something that I do very often, but here you can see that I can write something like parsers, right? And then else assert force. I mean, and also obviously if you were writing this in real code, you might write some like for some typed exception, right? I'm just being lazy here for Leetcode purposes, but you write a raised exception and then of a specific type that makes more sense, maybe like invalid character or whatever, something like that, right? And then now we assert consume is equal to the right parens for the expression. And honestly, that's all we need because, is it all we need? No, because here there's another expression. That means that it's going to call this recursively in the future, right? And okay, I mean that now that we want to parse a let function, right? And what does that mean? I mean, it's just parsing a let function, or expression rather. And then now we have the inner side of these things, right? So we already consumed the let. That means peak. So that means that peak is the space. So actually, we want to consume the. And I think technically, yeah, maybe this is fine. I don't know. This looks a little bit awkward, but maybe that's fine. And maybe we can have actually write it in a symmetry. Right? The reason being that, yeah. It's just, you want the code to be a little bit symmetric, otherwise it's just a little bit weird looking. But okay, so then now we parse left. That means that, I don't know how to quite think about this necessarily. I mean, an expression, right? So then now is our next token an expression or we, right? I'm trying to figure out the scope actually. Let's see. Outer scopes. Please examine. An expression. Yeah, scope. I'm not quite sure how they want it exactly, so I want to double check this. When check for the value of the expression x. Okay, so that means that this applied to this, and then multi x equals x2. Okay, maybe. Maybe this isn't quite right then, in the sense that how to figure out how we want to write about it. In terms of scoping, right? Because I think the scope is a little bit tricky for this one, for me anyway. How do I want to think about it? Maybe I should have thought about it a little bit more. But I think we could just implement it using a stack like you would if you're doing like a language class or something, right? And then in the stack, maybe we have like a lookup table, and that should be fine. Yeah, and then every time you yeah, okay. And then now this part's a little bit tricky, though it's a little bit not so bad because of the left paren, so maybe we can do it this way, right? Then now p is equal to peak, right? So if p is equal to left parens, and this is an expression, maybe that's a little bit of a hack. Maybe you should, I don't know, it's a little bit hard. Right, so then now, but the expression is what we're returning, quote unquote. Return maybe not really, but I don't know. But it's the value of this let, right? So it's expression, so that means that we can return parsing an expression. Else, well, this returned anyway, so then maybe we don't need an else. But And this is still a peak because we expect parse expression to consume the left parens. Maybe that's a little bit wonky though. It's been a while, I'm not into practice. Okay, that means that now then we want to parse two things. What is ye? Ye is an explicit value, right? I just want to make sure that ye is, oh no, ye is expression. Okay, so that's not so bad. Expression, or so I think the way that they kind of define expression is a little bit awkward maybe, but I haven't done Lisp. Maybe that's how Lisp finds it. And okay, so that means that if this is a value, so then we want to get one token, and then we want to do the thing, right? So okay, fine. That means that this isn't quite right actually, the way I wrote it. Honestly, let me rewrite this actually. All right, because it's our next token is a little bit awkward because this should be a for loop, is what I mean, right? So a while true loop, while true. Right, so then now we look at our next, okay, maybe that's fine. Oops. Right, and then now, okay, and then if P is equal to then this is an expression, and this is the thing we return, right? So we return, so this part I think we're right. It's just that maybe I forgot the while loop. And this will basically is the thing that returns the while loop. Otherwise, then now we want to parse re and then ye in that, then a ye in that order. So then we want to say maybe parse re, right? So maybe we have re is equal to parse re to get the variable name, and then ye is equal to parse expression, as we said, and maybe we'll write it out just because for consistency's sake. And then here, for each let, this is a very annoying one. It's not even that interesting. It's just annoying. Because we want to write something like lookup of re is equal to ye or something like that. We want to set it, right? But we have to be able to look outwards, right? So that's a little bit tricky part. So yeah, maybe on let. Trying to think. I mean, we probably need those on everything, but it's still very weird looking. So something like that, and then now instead of a lookup, we would write something like, okay, so then while v is in stack of, well, not while v is not, I mean, no, this is right. We only set, so it doesn't, it's not a fetch, so it should be okay. So what we want is stack of the top of the stack. The lookup table there, we set to v is equal to ye, and then that's it. We keep on going, and then at the end we stack that pop. I think we pop on parse on the at the end of the parse let. So then now we have an expression, and then we're done. So then and then we return it. So then maybe here. No, okay, fine. I think that's right. Okay, so then maybe return y is equal to parse expression. Then now we pop off the stack, and then we return r. So okay, so maybe that's the way to go with parse let. Very confusing for sure. And of course we need two things, parse expression, which we kind of already have, and parse variable, which is fine, right? We can add that. And parse variable, what does it look like? I think that there's a definitive thing somewhere, a subset of variable names. So okay. So we want to parse until an empty space. So then I'll peek something like this. And I think also honestly this is a prime case for TDD. I think I hear fireworks. I mean, I'm just wondering anyway, but yeah, this is a prime use of I think this is right, of TDD, and you just kind of test each component, but it is what it is. It's fine. Okay, so then now we still need parse add. We should run it or crash on parse add or that's actually unexpected a little bit. So we'll see. Like I actually expected to crash on either multi or add, but the let part is a little bit unfortunate. So line 31, so we could see. Is that just like directly? Current is 0, 0. Is that? I could print out the peak real quick. So okay, so it 2, and then it's this part, I guess. Right. So that means that something's a little bit awkward on the let. Okay, so then that means that there's something wrong here. We parse the re and then expression. Oh, that's right. No, this is expected. I think I just have to clarify because an expression can be a number. So that's what I was trying to figure out. Or I was trying to work it back in, but then I just forgot about it. So this is actually expected. So this is true if this is a generalized expression. How do I want to correct it? Because y can be a number is what I mean. So then now, instead of asserting it, we just have to check it, right? So we have peak is, and what is re? I want to check where they talk about it in terms of. But it's not even that it is a number, right? So that's the way. They usually have a different term for it, I think, actually. Like exactly how it is defined, but I think it's fine. Because then technically this isn't an expression in that, because this isn't a full set of expression. This is a, like it should be a sub-expression or something like that. And I think that's where it's a little bit awkward. And also, I guess this has to be a variable name. You cannot just find an expression, but it is a little bit awkward because an expression can be a variable name. They're not very specific about this, or at least in terms of language. Maybe it is assumed because you can add x and y and right, and these are expressions. So then now we have to figure out, but which is fine. But in this problem, they call everything an expression, and I initially had defined this to be equal to this, which is like a possible expression or something like that, maybe, right? So maybe that's a little bit wrong. So let's actually clarify this real quick. Maybe parse Let's just call it a sub expression. I don't know if that's the right term, but maybe that's fine. Right, and then now we have to actually have a parse expression, and the parse expression is trying to figure out, okay, well, what type is it? And the types it can be is that it can be a variable, it could be a number, or it could be a sub expression. Right? I think that's where the confusion was. Is that what they call expressions a little bit monkey, because it could be a lot of things, or they just don't define it. It's not that they're maybe they just assume you to figure it out, which is fine, right? So then now we peek, and then the two things, right? So if p is equal to, or we can make it to a match here, p, right? So so we have a case of the left parens, then we just return parse sub expression, and then case of I forget how, maybe this isn't quite right, or not the match, but in the sense that, because I think it has to be if statements, because now else if p if the first character is alpha, I think that's where it says here, then it's lowercase letter, right? So p of 0 is alpha, then we return parse wherever. No, I mean, parse variable is not quite the right name. Parse variable gets a variable name and not a parse. So actually that is kind of incorrect. Maybe I should get variable name, right? This is so annoying. So then, because I have to update this to here, because what we want then now here's we want to parse a variable name, kind of. Because we want to get the value of it in an expression, in the context of an expression, we want to get the value of the variable name. Because that's where you use an add, and then v is the actual thing. Okay, maybe that's fine. So then now we actually want to do parse variable, and that's fine. And then else this is a number. Parse expression, parse variable. It's way annoying. It's in terms of time spent. It's not even that interesting. Okay, so this is a number. So maybe just return parse number. We'll put it there, right? And then parse variable. First, and I think get variable name is fine for what it was, but here, if we use, we can use this as part of parse variable directly, because you can have something like this where it is right paren n, right? So then maybe maybe we write something like something like that, right? So while the peak is not, you go to the empty space or the right thing, we append it, right? Actually, this is what I mean to write, but I think this should be part of this, right? And then I have a typo, but we only want to consume the empty string. So if peak is equal to empty, then we consume it. Oops. And then now we actually use it, right? So then v is equal to get variable name, and then what? And then now we look at the stack, right? To get the variable. So something like how do I want to write it? Okay, so p is equal to s is equal to stack of negative. And we don't want to pop, we just want to traverse. So maybe we do a for loop. Range from length of stack -1, -1, -1 to go to top is if stack of I, of if v is in there, that means that it exists, then we can return stack I v. Otherwise, we want to assert false, just like it doesn't exist, maybe, right? And we will just print out something like, maybe it does not exist. Something like that, right? Okay. Not in, oh. Oops. Okay, we didn't, I mean, that is an expected thing because we haven't written that yet. So that's fair. Parse number, and let me double check. Do they say anything specific? Integer could be positive or negative. What is, oh, I guess add in, it's only add in multiplication, so it's always only an integer. Okay. They really had fun with this one. I mean, it's not very interesting, but okay, fine. Okay, so then maybe the first one is signs, right? Signs. Maybe is negative is equal to false. If peak is equal to right? Then we consume, and also is negative is equal to true. And maybe we can write sign is equal to 1, and then here sign is equal to -1. You need to return sign times x or whatever, and then now this is just shift and add, right? So while x is equal to 0, while peak is not equal to or not in, basically while we can keep on doing, then we consume a character. C is equal to this, C is the int of this, and then we just shift and add, and that should be good, maybe, right? Parse mode T is not done. Okay, fine. Yeah, okay. Or parse add, really. It's kind of tricky to use these examples just because, yeah, it is. You know, you need to build everything. Actually, what we want to do is test along the way, right? So we don't need to, actually this one is a good one, the example 2, because it doesn't require add or multi. So we can see if this returns a 2 correctly, or I don't know, maybe there's an infinite loop somewhere crazy. And I think it might, I don't know. I think that sketches this part because no, it would go out of bounds if we keep on consuming. Where is there a while loop? Well, here's a while loop. So then we just keep we go parse an expression. Oh, actually I'm wrong. Okay, that makes sense. Even though I don't know. Oh, because it keeps on peaking, so it doesn't consume. Because these things consume. So this is really I mean, this is wrong because for I thought that this is a sub expression, right? That's what this we have now reestablished as we redefined it, but it doesn't have to be, right? Because for someone like this, then this could be a variable name. I don't know how to check in a good way then, right? It's very weird. I guess I'm trying to do it live. I think the way that I would normally write it is just having a token. But no, you can't really do it that way because the evaluation of the inner next you have to evaluate the beginning for the end. So then the only way that we can check is if this is the last thing that we're consuming. So one thing I would say is that I am making it harder for myself. And what I mean by that is that n is 2000. I think the intention maybe is that if you do like an n square algorithm, this would be really fast. But I'm trying to do this in linear and not go you know. Otherwise, you can just like choose the left and the right, and then you could do a search or something like that, and it's n squared. I think maybe I didn't put emphasis on that, and that's why I'm struggling a little bit. And this part is where some of the struggling finds, because I had this isn't quite right. How do I change it? Like, how do I think the thing that I have to now figure out is how do I know that the next expression that we get, that we do, is the last one, right? Like here, and it's confusing because it can either be get variable name or a parse expression, and it's not quite easy figuring how. Okay. Okay, so this is definitely true, where if this is a left parent, we do a sub expression. Else, I guess it cannot be a number because you cannot let. No, it could be a number. So then now, else. Okay, so that is still true if there's a left parent, but how do we tell that this is a thing? So okay, we get variable name. This is so awkward. So then we get the variable name. Maybe. Well, with this is a definite expression, but it could be an expression that is a number, right? And Leetcode, and it's maybe I'm also doing it wrong. I blame it on Leetcode when it's my fault. But I saw these, that's why I was like, but I didn't consider just returning a thing. Let me give it a second. How would I write this? Because this could be a variable name. If it is a variable, or it could be a variable name, but if it's a variable name, you don't know whether you should parse the variable so that you can return it, or you don't know if you should parse the variable, or it is setting up just getting the variable name so you could parse the expression afterwards. I think that is the tricky part. Oh, I guess a variable name always they find it a subset of variable name somewhere. That is very awkward though. So then now we have to check whether it is a variable. Oh no, if it's variable name, then we check. So maybe instead of this, it is something like okay. If P is alpha, we have a variable name. So then we is equal to get variable name, and then now if peak is equal to right, then we have to parse this, right? We return stack of v, something like that, or stack of -1 of v. And this has to be on the thing, I want to say. Maybe that's not true actually, but yeah. Otherwise, e is equal to parse expression, and then we just and then we just keep going. Otherwise, if it's not a thing, then we just parse expression. Also, we stack that pop. We also stack that pop here. We have to do it in a sign, don't we? Yeah, and then this doesn't no longer holds. Something like this. This is kind of tricky. Okay, I mean, this is a little bit better than I expected, honestly. In terms of not having given an error. Okay, output is 0. That's actually kind of fine. Not sure why that is, but okay. That means that so here maybe we want to write just for debugging, and that's why I didn't want to write the other ones yet, because I want to be able to debug all these things before it gets more complicated. We assign x is equal to 3. We don't assign x is equal to 2 though, for some reason. Huh. So we get a variable name, we parse expression. I think it's because oh no, this is wrong. It should be p is equal to this, and then we do pop, and then we return p. I mean yeah, because otherwise parse expression does not have the variables necessary anyway. But this is still weird though. Okay. I think it's because I have an empty space and I don't consume it somewhere, so it probably messes up here or here, and then something wrong with parse expression as well. That's my guess. So maybe we'll do here, we have to peek to see. And yeah, and I think my thing is confirming that this is an empty space, so we have to consume. I did expression. What's parse expression again? Let's see, where is it? Okay, so this is so we parse this. So parse sub expression consumes the thing, and then now we consume the. Maybe we don't consume the empty space. Maybe that's not smart, because then now here we can write p is equal to peak, and then we consume the empty space, and then we get the real things afterwards. Maybe that's a little bit better. It may not. Okay, so now we sign x is equal to 3, x is equal to 2, but then this is the same issue that we had here actually, right? So then now v is not v, but r is equal to this. Okay, that's good. And then I'll return r, right? Okay, so now we're good here. We are happier, right? And this is our debug thing. I mean, I think you would have used like debug flag or something like that if you want to, so that you could compile it in both ways or just run in both ways. But obviously, this Leetcode is a little bit, subset of everything. How do I get my test cases back? I forget how to reset test cases. I know this is going to give me an out moat issue. That's fine. We expect that. And then now here actually honestly this should be easier to write now, because we have to write both two things. We have this, and we have a space to begin with. Let's reset, right? Because we didn't consume it, so that we can consume it here for some reason. But yeah, so then p is equal to peak. Assert p is equal to space, and then consume. And then now we have just two expressions to add to multiply. So then we have parse expression. I'm just trying to figure out the stack situation. I guess we don't pop or pull, right? Do we? I think only let creates a new stack of the values. I mean, I think in theory maybe you should just do it anyway, but in general, but I think this is fine. So something like this, maybe. Where's my parse expression? I'm just double checking. Do I consume the empty space? Okay. Yeah. I think I messed up slightly, but I'm trying to find where my code is. Where's my? Okay. So then now we have this, but there's a space in between, so that's why I'm like, something is a little bit off. But yeah, so maybe you have operand 1 or something. No, not operand. So go P1 maybe, something like that. And then we assert peak is equal to another empty space, and also maybe we write that here like that too. And then we can consume P2 is equal to this, and then return P1 times P2, and then we should be okay. Yeah, I know that the other one has an add, in fact, this one. So let's just convert this to a mode for now, just so that I can test this real quick for correctness. And yeah, and apparently this is wrong. Does the parse expression remove this thing? I think that's the thing that I'm worried about. Where's my parse expression? Okay, it's parse expression. Yeah. So okay, this consumes. What is the? But why though? Why would this parse expression get rid of the thing? It's the left, but the left is wrong because that means that we consume the space in between. Also, is there always only one space? Because that's gonna be annoying if we have to deal with it. Oh yeah, single space. Okay, no leading or trailing space. That's good. Okay, so this is a little bit awkward in that our parse expression gets rid of something. So maybe it is in this case we have a parse variable. Maybe let's double check everything. This is where you usually mess up. Okay, get variable name. Wow, this is not it. Oh, we do consume the thing as part of the thing. Now I think the thing that we should always do is just where do I do this? I forget why I do this. Oh, it's for this thing. Maybe that shouldn't have happened, but it's for parse let, because then we have this thing in between. So then we get variable name, and then we assert that there's a space in between. So maybe we do it this way again. Oh no. Well, actually, yeah. This is. Then now here we assert that it is equal to space, and then we consume otherwise. Okay. I mean, this looks right? So we're Gucci. And then now we just have to implement the add, which is honestly the same as the motif. We could find it and we just copy and paste it. You could probably generalize it a little bit, but that's fine. If I could find it anyway. Oh, there it is. This is why you have libraries and stuff. But, you know. Okay, so we add, and then this is just add. And we're hopefully happy. Happy for these two. How do I reset the let's try for everything. So close. I think this is the scope one though, maybe, because I think the setting x is equal to this expression isn't quite right, but and this is where we would have turned back our debugging flag on and then check out what is going on. So we assign x to 1, assign y is equal to 3, y is equal to 2 here, x is equal to 3, which is right? This is this part. And then now we do a final parse expression on the on this function, right? I think that's right. Yeah. I don't know why there's an extra. Oh, that's on the. Oh. I guess that's where this is wrong. Because parse expression should remove the right parens, but it doesn't. That's the reason. Because I expect a space and then yeah, I expect a space here, right? So there is some like weirdness about it that I think if we just get here, then it doesn't do it, right? Because we can even put it here, right? Yeah, as you can see, that's what's messing it up. Okay, that's a easy fix, maybe, hopefully. Right. What did we say is the issue? Parse expression doesn't get rid of the right parens, which I thought we did. So, or in my expectation, it should. So I think that's fine. I think parse sub expression. Parse sub expression doesn't do it. That's why. Oh no, we have it here. Oh, I'm dumb because we return. So of course there's no consume afterwards. Okay, I mean, it's just me being dumb. I mean, that's fine. It is now expected from the code, but I was just wrong. That's what I mean. All right, there you go. All right, like the code does what I expected to do incorrectly. So okay, let's give us a quick submit. Come on, baby. Yes. It is a relief because, you know, this is very easy to mess up. Like I wouldn't have been surprised if, you know, we had like 5 wrong answers and we had to kind of debug it the entire way kind of thing. But, you know, so far that was pretty good. 51 minutes, we kind of grinded out. Honestly, don't know if I expected to work on this problem like this, but that's fine. And I think the annoying thing is that this problem isn't that interesting for me. But it's fine. I don't know. Well, I mean, I think one thing that I would say is that the reason why this is so tricky is because I'm trying to do it in O of n times. Given that n is equal to 2000, I think if I had to guess, people probably just do it n square, right? Which is fine and it's fast enough, and it makes it way more easier to kind of go for the states. And this doesn't even have that many possible states, right? So I think I didn't like yeah, you could kind of think of it as like a finite state automata type thing of like what you're accepting in terms of your language. But there are a lot of ways to think about it, honestly. But I am thinking of it not in a great way. But yeah, that is all I have for this one. Let me know what you think. Apparently this isn't even a premium problem. Actually, I thought it would be. But thanks for watching. Stay good. Oh, actually, let me kind of. Sorry, I rushed it because I didn't even get to talk about it. But just to kind of think about this, it is a recursive descent, and it's just a language accepting thing. The only tricky thing I would say is just this part of a variable number of the let expression where I don't know. I think I got a little bit confused as well because they have e of n and an expression at the same time. So I didn't really. I don't know. It's a little bit awkward for sure. I wish they made it if this was a little bit more clearer, then it would have been much easier. But yeah, I think the idea behind these is to just set up a clean API for yourself to use, and then you can figure out what you're defining every step of the way. Here we have to peak, we have to consume, which is most of the things that we need. We have get variable name, parse variable, parse number, parse expression, which is any type of expression. So it could be what I call a sub expression, which means like a parent expression maybe. It could be a variable, it could be a number, and then we have some parse add, which makes it easier because then now we just parse left side, right side, add them, left side, right side, multiply them, right? You saw how I did it. Did in a couple of minutes and just testing. And then sub expression is the tricky part because it could be you have differentiate. Yeah, basically you have a parent expression if you want to call it that. So you have the left parent, right parent, parse to let, add, multi, and then yeah, parse let is definitely the trickiest part due to the variable number names. I actually don't know how to do it more generally, huh? I guess you would tokenize stuff and then kind of do it that way. But it's definitely like very tricky to evaluate because the expression, or even like the in-between expressions, depend on previous things being done. Maybe that's fine. And maybe this is kind of similar to how I would have done it anyway. And maybe how I did it is mostly right. It's just very tricky to get right. But yeah, that's it. That's all I have for this one. Let me know what you think. And yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.